So what is a PID controller? It is an acronym that stands for Proportional Integral Derivative. If you need to keep something constant, like a temperature for example, then this is the way to do it. Essentially, it uses a control loop feedback to ensure the output wanted is what you will get. Simply, you put a setting in the controller and it will keep the output constant based on feedback from some input, typically some kind of sensor. Something you probably encounter every day that is essentially PID control is your cruise control in your vehicle. First, you get to the speed that you want to be going. Then you set your cruise control. The cruise control sends output signals to your throttle to regulate the speed. A speed sensor provides your control loop feedback to tell the cruise if the car should speed up or slow down, or how much more or less throttle to provide. A common standalone type that we use in manufacturing and industry is a temperature controller PID. These controllers are pretty simple to use and set up. Plus, they do a great job at controlling temperatures of a variety of equipment. Let's take a look at how they work. For our example, we will look at a PID controller that controls the temperature of heat tracing on process piping. First, we need to enter a set point, 200 degrees Fahrenheit for our example. Now, the controller will give a signal to the output to start heating up the heat tracing. The control loop feedback is in the form of a thermocouple to read the temperature. For our example, the PID controller can work as an on-off control for the heat tracing. Along with the set point of 200 degrees, we will set the controller at a couple of degrees above and below 200 as well. When the thermocouple reads 202 degrees, it will turn the heat tracing off. When it reads 198, it will turn it back on. This is the simplest form of PID control. We also have the option of setting up a PID controller with a PLC. Instead of the standalone unit, we can use the input and output cards already on our PLC. The process variable, or control loop feedback, would be wired to our input card and programmed into the PID. Our output being controlled is wired to our output card. The PID and the PLC can do all of the math and make the decisions based on the variables and set points. No matter which way you decide to set it up, a PID is an excellent choice for an automated process. Let's look back at today's information. A PID controller is a proportional integral derivative controller. It can keep an automated process, like temperature, pressure, or flow, constant for you automatically. PIDs use a control loop feedback or process variable to monitor where the output should be. These usually come in the form of sensors and meters. PIDs come in many different forms, including standalone units and PLC programming. We can use our input and output cards along with programming software to set up a PID. I hope this video really helped you get a grasp of how to use a PID. They are a very handy tool to use. Don't forget to click the like button and subscribe